If light travels the fastest in the universe at around 300,000 kilometers per second, fast enough to circle the Earth in just 1 second, then how did scientists actually figure this out? Back in 1638, Galileo Galilei made the first attempt to measure the speed of light, but unfortunately, his experiment failed completely because light was just too fast to measure with the tools available at that time. About 38 years later, Ole Romer tried a different approach. He studied the delays in the eclipses of Jupiter's moon Io and used that data to estimate the speed of light. Although his method was brilliant, it still wasn't perfectly accurate. Then came the breakthrough by Hippolyte Fizeau. Fizeau designed a clever experiment to measure the speed of light. He used a light source. Imagine something like a laser. The light first passed through a rotating wheel with teeth. Then it traveled about 8 kilometers, hit a mirror, and reflected back toward the wheel and finally to the observer. Now here's the interesting part. Fizeau started rotating the wheel and gradually increased its speed until the returning light was completely blocked. What does that mean? It means that by the time the light traveled to the mirror and came back, the wheel had rotated just enough for one of its teeth to block the returning light. So essentially, the time taken by light to travel that full distance was equal to the time taken by the wheel to rotate by a specific amount. Using the wheel's rotation speed, the number of teeth, and the total distance traveled by light, Fizeau calculated the speed of light. And his result? Approximately 313,000 kilometers per second. Yes, it was slightly higher than the actual value, but for that time, it was incredibly accurate.